When you buy two brand new smartphones, like identical models from the exact same store, you expect them to behave exactly the same way.
Right, you take them out of the box and just assume they're clones.
Exactly. You boot them up and you expect perfection. But then, say a week later, yours is working perfectly and your friend's battery just keeps draining by noon.
Oh yeah, that happens all the time.
Right. But your immediate thought usually isn't, the manufacturer has deliberately rigged this specific phone to ruin my friend's life.
No, I mean, you assume there's a logical explanation,
Yeah.
like a bad battery cell or a software bug, or, maybe they just leave their screen brightness on max while running 3 different navigation apps.
Yeah, exactly. Because operational friction is just the natural starting point for any piece of complex technology.
Right, we look for the weak link in how it's being used, not some massive, malicious corporate conspiracy targeting one single consumer.
But the thing is, when you step into the high-stakes, hyper-competitive world of elite motorsport, that rational assumption completely vanishes.
It really does. It goes right out the window.
Suddenly, if two supposedly identical cars don't cross the finish line at the exact same millisecond, a massive, highly vocal portion of the fan base skips right past any technical explanation.
And they go straight to intentional sabotage.
Straight to sabotage. Welcome to the deep dive. We are so thrilled to have you with us today because, honestly, our mission is to cut straight through that toxic social media noise.
It is so loud right now.
It's deafening. So we are going to conduct a purely technical, strategic, and logical analysis of these explosive sabotage allegations that are currently rocking one of the grid's most prominent teams.
And to do this, we've actually synthesized a massive stack of sources for you.
All right.
We're pulling from official team statements, including this rather unprecedented open letter published by the team itself.
Which was wild to read.
Truly. We're also looking at highly detailed FIA technical regulation documents that outline this new era of racing, and some really deep structural engineering analyses of the current cars.
So we're going to explore this massive performance gap between the two teammates, break down the harsh engineering reality of what car parity actually means, and investigate some specific mechanical anomalies that popped up in Shanghai and Suzuka.
And finally, we'll look at the cold, hard economics of why self-sabotage in modern racing is, well, it's simply a myth.
Okay, let's unpack this. We need to establish the baseline of the controversy first, right?
Yeah, because the entire conspiracy theory is anchored in the current standings.
Mm-hmm.
There's this undeniable, just gaping performance chasm between the two drivers in this specific garage.
The gap is glaring. I mean, you have the lead driver sitting comfortably on 15 points, putting in absolutely stellar performances.
Incredible drives.
Right. We're talking about a driver who successfully held off a multi-time world champion in a straight fight recently. But then on the other side of the garage, the second driver has only managed to scrape together a single point so far this season.
And fans of that second driver have completely weaponized that 15-to-1 point ratio.
Oh, absolutely. They point to the scoreboard and claim the team is intentionally holding their driver back.
The prevailing online theory right now is that the team is purposefully nerfing the second car to favor the lead driver, to ensure there's an undisputed number one.
I really struggle with that narrative, though, because it assumes a level of mechanical uniformity that it doesn't exist.
Right.
People often compare it to, like, two Olympic sprinters wearing the exact same brand of shoes, and if they don't tie, people cry foul.
But a formula car is not a pair of track spikes.
Exactly. It feels more like handing two world-class musicians the exact same model of a high-end electric guitar.
That is a much more accurate way to look at it.
Because if you hand them the exact same guitar, one musician might tune it to a drop D, lower the action of the strings so they rest right against the fretboard, and use incredibly heavy gauge strings.
Yeah, and the other musician might want standard tuning, high action, and ultralight strings.
Right. So by the time they step on stage, those identical instruments sound, play, and behave in completely different ways.
What's fascinating here is that the engineering data backs up your guitar analogy perfectly. Identical specification does not mean identical setup.
Right. The setup is everything.
Exactly. The lead driver we're talking about has been racing at this elite level for nearly a decade. He already has a race win under his belt. He spent years learning exactly how to extract the maximum performance from a highly sensitive aerodynamic platform.
He knows his preferences down to the millimeter.
He really does.
So what are the actual variables that drivers are changing? Because, I mean, to someone watching on TV, the cars look exactly the same from the outside.
It mostly comes down to invisible forces and suspension geometry. Even if every single carbon fiber weave on the chassis is identical, the drivers will request completely different settings for things like brake bias, ride height, suspension stiffness, and differential unlocking.
Oh, wow. So it's all underneath the shell.
Yeah, exactly.
Right.
Like one driver might prefer a car with a loose rear end that naturally oversteers into a corner. That allows for a really aggressive, snappy turn-in.
But the other driver might hate that.
Completely hate it. They might require a highly stable, planted rear end, which naturally induces a bit of understeer.
And if a driver doesn't have the setup they prefer, they lose confidence, right? And losing confidence means lifting off the throttle a fraction of a second too early.
That is the crucial mechanism right there.
Hmm.
Those setup choices radically alter how the car interacts with the asphalt.
Yeah.
And when you add in race strategy, different pit windows, different tire allocations, and the physics of dirty air, the idea that both cars should naturally finish within a tenth of a second of each other is just an engineering fantasy.
Let's actually define dirty air for you listening, just in case you weren't deep into the aerodynamic side of things. When a car punches a hole through the air at 200 miles per hour, it leaves behind this turbulent wake.
Right, it's very messy air.
Exactly. So if you are the second driver stuck behind your teammate, you are driving through that chaotic, swirling air. Your wings can't generate the same downforce, your car slides more, and your tires degrade way faster.
It's brutal on the car.
It really is. So just by being a fraction slower in qualifying, the race day physics exponentially punish the trailing car.
Which brings up some vital historical context. This gap isn't a sudden, unexplained phenomenon.
No, not at all.
If we look at the historical data from the previous season, there was already a 17-5 qualifying disparity between these exact same two drivers.
Wow, 17-5.
Yeah. The baseline of the lead driver simply being faster over a single lap was established long before the internet decided there was a conspiracy.
But the conspiracy theorists didn't just stop at the pints gap or the qualifying history. They found their so-called smoking gun during the Chinese race weekend.
Ah, yes. Shanghai.
Right. This is where the narrative evolved from vague accusations of favoritism to pointing at actual physical hardware. In Shanghai, the second driver finished a massive 49 seconds adrift of his teammate.
That is a huge gap.
Huge. And the fuel for the fire was that the team actually published an open letter admitting to a specification difference between the two cars.
Right. The team openly disclosed that the second driver had to revert to an older, pre-season testing gearbox component.
Which is all the proof a certain segment of the internet needed to just scream sabotage.
Of course.
And honestly, put yourself in the shoes of a fan for a second. If the team's ultimate goal is to field two equally fast cars and they know the entire world is watching their every move, why not just grab a matching current spec spare off the shelf?
Right. Why use the old part?
Doesn't a lack of identical parts at least look incredibly suspicious?
Well, it looks suspicious if you ignore the brutal logistical reality of the modern cost cap era.
Oh, the cost cap changes everything.
Entirely.
Hmm.
We're no longer in the early 2000s where teams had infinite budgets and fully built spare cars.
Yeah.
You know, the old T-cars just sitting in the garage waiting.
Yeah, those days are long gone.
Today, financial regulations strictly limit how much a team can spend, which directly chokes their manufacturing throughput. A carbon fiber gearbox carrier isn't just stamped out on an assembly line in 10 minutes.
So how long does something like that actually take to make?
We are talking about a meticulous process. Laying up individual sheets of carbon fiber, injecting resins, and baking the component in a pressurized autoclave for hours, sometimes days, before it undergoes rigorous stress testing.
Days. Wow.
Yeah, so when a team fast-tracks a performance upgrade, they frequently only have the resources and time to manufacture a single set of parts before the freight planes leave for the race.
So they literally just didn't have another new gearbox in existence to give him.
That is the reality of the grid. This wasn't a strategic board-level choice to punish a driver. It was a late-night reliability swap forced by a hairline fracture or a sensor failure discovered at the track.
Well, it makes total sense.
And to give you a sense of how terrifyingly tight these inventories are across the entire sport right now, consider another team on the grid this season. They suffered an unprecedented 15 total incidents, including 6 major crashes across just 3 races.
Oh, I remember that.
The attrition was so severe that they physically ran out of spare chassis. They had to withdraw one of their drivers entirely from a race weekend.
They just had to park a multi-million-dollar asset because the raw materials simply didn't exist to rebuild it.
Exactly.
That really puts the Shanghai gearbox into perspective. But how much time does an older gearbox actually cost you on the track?
Well, in a field separated by thousandths of a second, Any deviation bleeds lap time. The older, legacy gearbox from preseason testing might be a few hundred grams heavier, or perhaps its internal casing doesn't cool the hydraulics quite as efficiently, forcing the engine to run slightly hotter.
And that slows you down.
It might cost you half a tenth of a second per lap, but you multiply that tiny fraction over a 50-lap race distance, factor in the dirty air we discussed earlier, and suddenly you have a massive 49-second delta. It is pure logistics, not politics.
Okay, so if the hardware in Shanghai was just a logistical fluke driven by the manufacturing bottleneck, surely the identical cars in Suzuka proved the sabotage theory, right?
You would think so, but no.
Right, because that brings us to a completely different type of engineering. We move from physical bolts and carbon fiber to lines of code, calibration, and the extreme new physics of the new technical regulations.
Suzuka was basically a masterclass in how a lack of technical understanding creates a perfect storm of paranoia.
The incident started when the second driver complained over the team radio that his front wing was under-delivering.
And immediately the internet lit up.
Oh, totally. Fans took this as the ultimate audio proof. They said the driver was confirming from the cockpit that the car was nerfed. But when you dive into the sources, the engineering data tells a completely different story.
Both cars had the exact same physical front wing specification bolted to the nose in Japan. The issue was calibration.
Right.
The team's open letter explained that the sensors mapping the aerodynamic load were slightly out of sync with the wind tunnel predictions.
So it was reading the data wrong.
Sort of, it just required the driver to dial in different flap angles to find the balance.
Yeah.
It was an operational headache, sure, but it wasn't sabotage.
But here's where it gets really interesting. Because the front wing complaint was honestly just a distraction from the real controversy.
Yes, the power unit.
Exactly. The genuine danger at Suzuka came from the power unit. The new technical regulations mandate a radical new structure, a 50-50 power split between the internal combustion engine and the electrical power system.
We have to look closely at the MGUK. That stands for Motor Generator Unit Kinetic.
Right.
Its job is to capture the kinetic energy generated under braking and convert it into electrical power to be deployed later. Under the new rules, the MDUK has been bumped up to an absolutely massive 350 kilowatts of power.
Which means the battery is doing half the work of pushing the car forward.
Exactly half.
But I'm confused about the mechanics of this on a straightaway. Like, how does battery management leave a driver suddenly looking like a sitting duck on camera?
Because you cannot generate 350 kilowatts of electrical power out of thin air. The system demands massive, aggressive harvesting phases.
Harvesting.
Right. Yeah, when a driver reaches a certain speed on a straight or approaches a braking zone, the MGUK engages to soak up energy. The mechanical resistance of that harvesting is so severe that it acts almost like throwing a parachute out the back of the car.
Whoa, really?
Yeah. The driver lifts off the throttle slightly and the harvesting aggressively drags the speed down.
Okay, so if we connect this to the bigger picture, it's not just the battery. The new regulations also introduced active aerodynamics to handle all this, right?
Yes. The rules outline a Z mode, which angles the wings neatly for maximum downforce in the corners, and an X mode, which flattens the wings out for low drag on the straights.
So the wings are literally moving.
Right. When you combine the active aero flaps snapping open and closed with the violent deceleration of the battery harvesting, you create extreme speed differentials between cars on track. Two cars on the same straight might be operating on completely different energy deployment maps.
And the sources outline a terrifying incident that perfectly illustrates this physics quirk. Can you break down what happened with the 50G crash?
It was a horrific visual of this exact speed differential. A rival driver came around a blind high-speed corner at Suzuka. Our second driver was ahead of him on the track, but his car was in a heavy harvesting phase to recharge the battery.
So he's basically deploying that parachute you mentioned.
Exactly. But the rival driver was on a full deployment lap, meaning he was utilizing maximum battery power and his aero was fully open in X mode. The closing speed between the two identical-looking cars was nearly 50 miles per hour.
50 miles per hour difference on a straightaway. That's insane.
The rival driver had milliseconds to react. He had to take evasive action, swerved off the racing line onto the grass, and slammed into the tire barrier. The onboard telemetry recorded the impact at 50 times the force of gravity.
That is just unimaginable violent.
It is. Thankfully, the driver walked away. The FIA immediately reviewed the telemetry data from both cars. They officially deemed that no further action or penalty was necessary because the second driver hadn't brake-checked his rival.
It was just the car doing its thing.
Right. The FIA stated that these massive, sudden closing speeds are a known characteristic of the new power units. It's an aggressive engineering reality they are currently reviewing for future safety tweaks.
But, of course, the fans online completely ignored the FIA's aerodynamic and telemetry review. They saw the television broadcast.
And they trusted their eyes over the data.
Right. They saw their driver seemingly lose 50 miles per hour of straight-line speed for no visible reason, and they screamed sabotage. I mean, to the untrained eye, it looks exactly like a malicious engineer on the pit wall just flipped a kill switch.
But the telemetry proves otherwise. The car wasn't sabotaged. It simply transitioned into a heavy harvesting map because the battery was depleted. The driver is fighting a highly sensitive, incredibly complex hybrid algorithm.
It's kind of like the motorsport equivalent of your smartphone battery dying at 1 p.m. because you left your GPS running in the background all morning.
That's a perfect analogy. The manufacturer didn't hack your phone. The system just consumed the available energy based on the operational demands.
So what does this all mean when we zoom out? We've explored the performance gap by looking at setup preferences and experience. We've explained the Shanghai gearbox through the logistical nightmare of the cost cap and carbon fiber manufacturing.
Right.
And we've demystified the Suzuka speed issues through the aggressive harvesting physics of the new battery rules. If the physics and the logistics completely dismantle the how, let's look at the why.
The motivation.
Let's walk into the boardroom for an economic reality check. Who actually benefits from a team slowing down their own car? Cui bono?
The answer is absolutely no one. The conspiracy theory completely collapses the moment you apply basic business logic to the standings.
Explain that, because they're fighting for position right now.
Yeah, this team is currently fighting tooth and nail against massive manufacturers for fourth place in the Constructors' Championship.
Which is a miraculous position for them to be in, given their history. But what does fourth place actually mean in dollars and cents?
Well, the commercial agreements dictate the prize money distribution. The estimated difference in payout between finishing fourth and finishing fifth in the championship is a staggering $13 million.
$13 million.
That is the capital that pays for vital wind tunnel time. It funds the manufacturing upgrades. It pays the salaries, the mortgages, and the bonuses of the very mechanics and data scientists who are currently being accused of writing malicious code.
Wow.
To intentionally sabotage your second car means you are intentionally sacrificing championship points. And sacrificing points is literally setting $13 million on fire.
No team principal, I don't care how ruthless they are, how much they love their lead driver, is going to voluntarily forfeit that kind of operational budget.
Furthermore, consider the human element. Executing a sabotage plot isn't a one-man job.
Right, you can't just do it in secret.
No, you would need the absolute complicity of dozens of mechanics, data analysts, structural engineers, and race strategists. These are hyper-competitive professionals whose entire career trajectories depend on proving they can make a car go fast.
It makes no sense.
The idea that an MIT-educated data engineer would agree to write bad code to make their own machine slower defies all rational thought.
And the team's open letter actually gave us a great look at the internal ecosystem to disprove this. They explicitly stated there is no split garage mentality.
Right, they work together.
Exactly. The two drivers don't sit in isolated bubbles. They regularly visit each other's desks in the engineering office. They look at the exact same telemetry traces.
Because withholding information is a relic of the distant past. In the 1980s, teammates might have hidden a suspension trick from each other.
Sure, back in the analog days.
But today, with the new power units requiring such complex energy deployment maps, the team relies on a centralized mission control room back at the factory. Dozens of analysts are crunching the data from both cars simultaneously to find the optimal race pace.
Right, so if you sabotage one car, you are blinding your entire engineering department to 50% of your aerodynamic data collection.
You ruin your own wind tunnel correlation.
Yes. You are actively hurting the development of the lead car by breaking the second one.
The team is an ecosystem.
Yeah.
Every single component, human and mechanical, requires the other to survive and adapt to these wild new regulations.
So bringing it all together for you listening, we've covered a massive amount of technical ground today. We've seen how a lack of public understanding regarding logistical bottlenecks, like exactly how long a carbon fiber layup takes in an autoclave, creates a vacuum of confusion.
It really does.
And we've seen how the complex new physics Specifically, the massive speed deltas caused by 350 kilowatt battery harvesting and active aeroflaps create shocking, unexplainable visual moments on the television broadcast.
Moments that look awful if you don't know the science behind them.
Exactly. And finally, we've seen how a fundamental misunderstanding of the sport's basic economics leaves the door wide open for paranoia.
And as we know, nature abhors a vacuum. When a 50G crash or a 49-second gap happens, fans demand immediate answers.
They want to know why right now.
Yeah, and in the absence of highly technical explanations on the broadcast, that vacuum is filled with speculation. In the echo chambers of social media, speculation quickly mutates into these toxic, deeply entrenched conspiracies.
It is so incredibly easy for you, sitting at home, looking at a highly complex multi-million-dollar system from the outside, to mistake normal operational friction for malicious intent.
It's much easier to blame a person than a system.
It is. It is comforting to think there is a villain pulling the strings on the pit wall rather than accepting the boring reality. Logistics are messy, physics are unforgiving, and sometimes one elite athlete simply adapts faster than another.
But you know, our deep dive into this data leaves me with one final, rather unsettling thought.
Oh, what's that?
We are dealing with internet sleuths poring over onboard telemetry and audio clips to prove sabotage today. But what happens tomorrow?
Okay, I'm listening.
It makes you wonder if teams are this desperate to hide their true aerodynamic data and set up preferences from their rivals. How long until we see artificial intelligence being used to intentionally broadcast fake, scrambled telemetry data during practice sessions?
Oh my God, fake data.
Right. If a team can use AI to broadcast a fake drop in straight-line speed just to throw their rivals and the internet off the scent, the line between conspiracy and strategy is going to disappear entirely.
That is an absolutely wild thought. A fake digital ghost car broadcast to the world.
It's entirely possible.
If that happens, no one will ever trust what they see on the screen again. So the next time you buy two identical smartphones and one starts acting up, remember this racing season. Before you blame a global corporate conspiracy, just check your background apps.